did satellite imagery and they realized, oh my God, that's the caldera of a volcano, like this Yellowstone thing. We thought it was just this crazy place with hot springs. Like, no, that's a super volcano that is a continent killer.
There are indications that a supervolcano eruption is about to occur, frightening officials to order an immediate evacuation from Yellowstone. Rising seismic activity and increased geothermal changes have been occurring for some weeks now. They are talking about how serious the threat is and how disastrous a mega-volcanic eruption would be at Yellowstone. The terrifying happenings that suggest the supervolcano is far from dormant increase the urgency of the evacuation order. Yellowstone National Park is on the brink of a catastrophic eruption due to increased seismic and geothermal activity. Scientists have documented uplift rates of up to 6 inches, attributed to the buildup of gas and magma beneath the surface. Geothermal features, such as hot springs, ferals, and geysers, have become more frequent and intense, while others have become more unpredictable. Steamboat geyser eruptions have increased, with heights of up to 300 feet. Significant temperature increases and color changes in hot springs suggest chemical changes in the water. More active ferals or steam vents are releasing more gas and steam. The park will be completely evacuated due to an alert from the Yellowstone Volcano Observatory. The park will work with local and state officials, mobilize resources like park rangers, state troopers, and the National Guard, and use helicopters and barriers to stop illegal access. Scientists keep an eye on the situation and stress the need of remaining informed and following evacuation orders. Questions concerning the nature of the threat and the motivations behind the dramatic measures are raised by the unprecedented evacuation. The worldwide climate and environment can be severely affected by vast ash clouds, lava flows, and other hazards caused by volcanic eruptions that are thousands of times greater than usual. These eruptions have the potential to alter Earth's atmosphere permanently, bringing down global temperatures and altering weather patterns. In the last 2.1 million years, Yellowstone has seen 3 significant eruptions, all of which have had a significant effect on the surrounding ecosystem. The largest and most violent eruption occurred at Huckleberry Ridge 2.1 million years ago, ejecting over 2,500 cubic kilometers of volcanic debris. The Mesa Falls and Henry's Fort caldera in modern-day Idaho were created by the 1.3 million-year-old Mesa Falls eruption, which released 280 cubic kilometers of volcanic debris. Approximately 1,000 cubic kilometers of material were released during the Lava Creek eruption 631,000 years ago, which formed the Lava Creek and shaped the present-day Yellowstone caldera. It is crucial to comprehend the science underlying these occurrences in order to forecast future eruptions. The vast magma chamber beneath Yellowstone supervolcano powers its geothermal and volcanic activity. A vast active magma chamber that is 5 to 17 kilometers, 3 to 10 miles, below the Earth's surface is known as Yellowstone. The chamber is made up of 2 linked reservoirs: the deeper reservoir, which holds more totally molten rock, and the top reservoir, which is mostly composed of solid rock with pockets of molten material. Molten rock crystals and dissolved gases make up the magma in the chamber, which builds pressure as more magma is added. There are a number of possible catalysts for the massive Yellowstone volcano eruptions, including magma movement, earthquakes, and the introduction of fresh magma from deeper Earth. To better grasp the possible results of a Yellowstone eruption, which can range from small-scale occurrences to massive supervolcanic eruptions, scientists have created scenarios. Hydrothermal explosions and moderate volcanic eruptions are 2 extreme scenarios that might damage areas tens of miles around the caldera, disturb ecosystems, and seriously endanger human life. Observation YVO and other organizations use equipment such as seismographs, GPS units, and satellite photos to regularly monitor the volcano. This provides vital information for forecasting possible eruptions and guiding emergency response strategies by assisting in the detection of changes in the magma chamber and surrounding crust. The most immediate invisible impact of a Yellowstone eruption would be the enormous ash cloud produced by volcanic ash, composed of tiny fragments of rock minerals and volcanic glass, which would be ejected high into the atmosphere darkening the sky and covering the landscape in a thick layer of ash. Significant ashfall from the Yellowstone eruption could contaminate water sources, clog air filters, create respiratory problems, and disrupt power. Ash buildup might get as deep as several feet in a 500-mile radius around the eruption site. Hot gas and volcanic rock move quickly in pyroclastic flows, which can reach temperatures of 1,000 degrees Celsius and reach speeds of up to 700 km/h. The area directly surrounding Yellowstone, which includes portions of Wyoming, Montana, and Idaho, would be the hardest struck within a 100-mile radius of the eruption, perhaps wiping out entire communities. Although pyroclastic flows are usually more explosive than lava flows, the magma from the eruption is still seriously threatened by lava flows. Both swiftly flowing lava flows and more slowly moving, viscous domes would swallow everything in their path, destroying infrastructure such as roads, bridges, and buildings, and irreversibly changing the terrain. A Yellowstone eruption would undoubtedly result in human casualties, especially for people in the immediate area. Thousands of people would perish from the combined effects of pyroclastic flows, lava, and ash. Everyone in the primary impact zone would die in the initial blast. There would be a major shortage of emergency services, disorderly evacuations, and significant damage to the infrastructure. The weight of the ash would cause homes and buildings to collapse, seriously jeopardizing vital infrastructure like hospitals and emergency response centers. Roads, highways, and trains are among the transportation networks that would be buried by rubble, making rescue and relief activities more difficult. Due to ash buildup on runways and limited visibility, airports in the area might have to close. Massive environmental harm would come from the eruption, including the immediate extinction of plants and animals, the destruction of ecosystems, the contamination of forests with chemicals and ash, and the possibility of secondary risks like flooding and landslides. The emphasis would switch to survival, necessitating the establishment of recovery shelters for the displaced people. The financial toll would be enormous, resulting in losses of billions of dollars and the livelihoods of innumerable people. Rebuilding infrastructure, resuming services, and restoring the environment would need substantial resources and coordination, and recovery might take years or decades. The damage and loss would have a profound psychological impact on the afflicted communities, leading to trauma and mental health difficulties. The impacts of a major volcanic eruption like Yellowstone on people and the environment would be extensive. Since volcanic ash is made up of microscopic abrasive rock and glass particles that may seriously harm aircraft engines and systems, the large ash cloud created by the eruption would immediately endanger air traffic. This danger was illustrated in 2010 when Iceland's Eyjafjallajökull erupted, causing the biggest aviation closure since World War II. And considerably greater ash cloud from a Yellowstone eruption would release ash high into the stratosphere, causing previously unheard-of delays to air traffic. A Yellowstone eruption would have catastrophic and protracted climate repercussions, possibly resulting in a volcanic winter. Large amounts of sulfur dioxide, SO2, would be released into the atmosphere as a result, cooling the planet's surface and having an impact on agriculture. Poorer temperatures and less sunlight would result in poorer agricultural yields. Global repercussions on food security would occur, with impoverished areas being especially susceptible to starvation and malnourishment. In 1815, the Pinba eruption severely damaged infrastructure and destroyed over 200,000 dwellings, causing substantial economic hardship. In addition, approximately 250,000 people had to be evacuated as a result of the eruption, and over 800 people died. An estimated $700 million to $1 billion was the economic damage, with the agriculture industry being particularly badly hit. On Sumbawa Island in Indonesia, Mount Tambora erupted in 1815 with a force of 7, spewing out an estimated 160 cubic kilometers of material. The island's inhabitants was wiped out, and the ash caused extensive damage to crops and settlements before spreading over the world. An estimated 71,000 people perished as a result of the eruption, either directly or indirectly, from malnourishment and illness. The year without a summer in 1816 caused a massive amount of sulfur dioxide to be released into the atmosphere, reducing sunlight and leading to a drop in global temperatures. This led to frost and snow, destroying crops and leading to food shortages. The potential eruption of Yellowstone supervolcano demands preparedness and response strategies due to its catastrophic consequences. Government agencies in the scientific community have implemented robust monitoring systems, developed evacuation plans, and continue to educate the public about the potential consequences of such events.